The appendix is one of the most commonly perceived vestigial organs found within the human body. In plant-eating animals, the appendix often makes up a majority of the intestine, where large amounts of cellulose are broken down by bacteria. Humans are unable to digest cellulose, and our appendix is greatly reduced and seemingly non-functional. However, anti-evolutionists argue the appendix serves an important function in aiding immunity due to the presence of lymphoid tissue. Antibodies are produced in all lymphoid tissue. However, it is misleading to suggest the appendix is vital to acquired immunity. The production of antibodies is a direct result of T and B lymphocytes being entrapped in lymphatic tissue after an antigen is detected in the body. The lymphocytes themselves are produced initially prior to birth from foetal stem cells and continue to reproduce throughout one's lifetime. Because the lymphocytes are simply trapped in lymphoid tissue, the percentage trapped in appendicular lymphoid tissue is minuscule in comparison to the rest of the lymphatic system. According to the American Journal of Epidemiology, there are an estimated 250,000 appendectomies annually performed in the United States. Surgery is the only way to resolve a bout of appendicitis, which would otherwise result in painful death due to peritonitis, intra-abdominal abscess, or severe infection following a rupture. In fact, so great is the risk and so severe the consequences of developing appendicitis, it has become routine for surgeons to remove a healthy appendix if they happen to be in the abdominal cavity performing an unrelated procedure. The appendix is another sound piece of evidence that reinforces the understanding our ancestors at one time had a diet solely consisting of plant matter. However, now that our diets have so dramatically changed, the appendix has become more harmful than beneficial. And this is exactly how natural selection works. For if we did not intervene in our own natural evolution by providing medical assistance to the sick, those more likely to suffer from appendicitis would die, unable to propagate their genes. And those of the population with reduced versions of the appendix would survive, and hence their offspring would have reduced versions as well, until the appendix disappears altogether. A herbivore ancestor is also supported by the presence of wisdom teeth, another set of structures that have become more harmful than beneficial. These molars were required for chewing and grinding plant material. Although over 90% of adults develop third molars, usually these teeth never erupt from the gums, and in 1/3 of all individuals they are malformed and impacted. These useless structures can cause significant pain, increased risk for injury, and may result in illness and even death if the impacted teeth become infected and go untreated. The plantaris muscle is used by animals for gripping and manipulating objects with their feet, something you see with apes who seem to be able to use their feet just as well as their hands. Humans have this muscle as well, but it is now so underdeveloped that it is often taken out by doctors when they need tissue for reconstruction in other parts of the body. The muscle is such an unimportant part of our anatomy that 9% of all humans are born without this structure. Homo sapiens are taxonomically classified as apes, and one of the defining characteristics of apes is a lack of an external tail. However, human embryos display the initial signs of a tail during our early development. Between 4 and 5 weeks of age, the normal human embryo has 10 to 12 developing tail vertebrae that extend beyond the anus and legs, accounting for more than 10% of the embryo's total length. The embryonic tail is composed of several complex tissues besides the developing vertebrae, including a secondary neural tube, a notochord, tail gut, and mesenchyme. By the 8th week of gestation, the 6th and 12th vertebrae have disappeared via cell death, and the 5th and 4th tail vertebrae are still being reduced. Likewise, the associated tail tissue is also undergoing cell death. However, sometimes there may be a problem in the programmed regression of vestigial embryonic structures, just as in the previously examined case of the dolphin's vestigial limb buds failing to regress, causing the adult animal to be born with hind limbs. So too has the failure in the regression of the human tail been observed, where children have been born with a vestigial appendage. Although the expression of a human tail is a very rare occurrence, the coccyx is a more permanent reminder of our tree-swinging days. Over time we lost the need for a tail, but we did not lose the need for the coccyx, which, much like the rudimentary femur found in whales, now functions as a support structure for various muscles, providing support for a person when sitting down and leaning back, as well as supporting the position of the anus. Humans also have remnants of ear-wiggling muscles. There are 3 small muscles around each of the human ears that apparently have no function whatsoever. In other mammals, these muscles are often enlarged and serve an important function, such as in deer that use them to turn their ears toward a source of sound. However, few humans can wiggle their ears, and none can turn them toward sound. Another seemingly wasteful structure is the recurrent laryngeal nerve, which regulates the ability to swallow in mammals, and in humans has the added function of controlling speech. In our mammalian ancestors, the nerve took a direct route from the brain to the throat, passing directly in front of the aorta. However, during the course of evolution, the aorta shifted inferiorly. Being such an important structure, the nerve could not be broken, so instead it has become longer in order to loop back up and reach the throat. In giraffes, the recurrent laryngeal nerve is 15 feet long, a full 14 feet longer than necessary. The human nose gives evidence of past ancestral forms as well. The olfactory receptor genes once encoded for proteins involved in now lost olfactory functions. Our predicted ancestors, like other mammals, had a more acute sense of smell than we do now. Humans have more than 100 olfactory receptor genes, approximately 70% of which are non-functional, or pseudogenes. Other mammals, such as the mouse, marmoset, and fox, have many of the same olfactory receptor genes as humans, but all of theirs are functional. An extreme case is the dolphin, the descendant of land mammals. Dolphins no longer have any need to smell, yet they contain many olfactory receptor genes, of which none are functional. They are all pseudogenes. For the most part, humans have relatively little to no body hair, yet some people, especially men, have a considerable amount of body hair from which they gain negligible warmth. No advantage can be gained from the amount of body hair found on modern-day humans. However, in light of evolution, we know our predicted ancestors had a coat of hair that covered their bodies, and what little hair we currently find on ourselves today is just a vestige of our primate ancestry. Goosebumps are caused by the contraction of the erector pilis muscle located around the shaft of the hair follicle. This phenomenon is a vestigial defense mechanism that has since been rendered obsolete after generations of evolution. However, this method of defense has been retained by some modern-day mammals, such as dogs and cats, that intimidate their foe by causing their fur to stand on end, thereby increasing the size of their appearance. This is also the way porcupines project their quills toward an oncoming predator. However, humans no longer have control over the erector pilis muscle, and due to our lack of hair, any benefit our ancestors might have gained by employing these structures has now been rendered useless within Homo sapiens. Another structure with no apparent function is found in the male body. It is the nipple. Of course, nipples serve a vital function within women, however men have absolutely no use for theirs. In fact, men even have small amounts of mammary tissue. Under natural conditions, men do not produce the appropriate hormonal stimulus to induce lactation. However, if men are exposed to increased levels of prolactin, the same hormone that becomes elevated when women are pregnant and give birth, men can indeed produce milk. Male lactation was of some interest to Charles Darwin, who speculated that both sexes of our early mammalian ancestors may have nursed their young. In fact, males of a rare species of fruit bat, known as the dayak, have been observed breastfeeding their offspring. Despite all these vestigial structures, the human body also has several flaws in its construction. For example, the retina contains millions of photoreceptor cells responsible for absorbing light, which is sent to the brain for interpretation via the optic nerve. However, at the location where the second cranial nerve innervates the retina, known as the optic disc, there's an absence of any photoreceptor cells. As a result, there's a break in the visual field of each eye, known as the physiological blind spot. The brain compensates for this flaw by filling in the surrounding details with information from the other eye. However, with one eye closed, the blind spot becomes noticeable with a simple test.
And you have to keep looking right at the bridge of my nose, so keep your eye fixed. And now we're going to move it just out a little bit, about 15 degrees. And right about there...
Yeah, it's gone.
It's gone.
Yeah.
You can't see it?
No.
Now can you see it?
Yes.
Now can you see it?
Yes.
Now can you see it?
No.
There's a blind spot.
Yeah.
That's really lousy.
Yeah.
All vertebrates display this blind spot in their eyes. However, cephalopods, such as the octopus, have eyes very similar to vertebrates, although they do not share the same constructional flaw. The reason cephalopods do not have a blind spot is a result of different origins of eye evolution. The eyes of cephalopods began as invaginations of photoreceptors within the head, whereas within vertebrates the eyes began as extensions of the brain. Therefore, the optic nerve of the cephalopod eye was able to attach from the rear of the retina instead of passing through the retina, alleviating the blind spot found in the vertebrate eye. Another flaw in our anatomical structure is the human knee, which is not well made for kneeling, and prolonged kneeling can lead to expansion of the bursa in front of the patella, a condition known as housemaid's knee. Likewise, there is a flaw in the human elbow. At the knob on the lower end of the humerus, the ulnar nerve is exposed just below the skin. A sharp blow by a hard object causes that numbing, painful sensation known as hitting the funny bone. The adult human skull is also too thin to provide adequate protection to such a large brain, where the absence of brow ridges leaves the eyes poorly protected. However, we do see a prominent brow in the skulls of primates, as well as other human species, such as the Neanderthal.